of time. Then we had non-uniform speed. Unequal amount of distance is being changed, or unequal distances covered in unequal intervals of time. This we had seen. An average speed, this was very important, which I had discussed with you, that average speed was total distance divided by total time. So however we had seen questions, we had seen that somewhere we didn't have distances, like here we didn't have, here in this question we didn't have. So using the formula of distance or the formula of the speed, we'll calculate the distance first and then we'll be putting it. Yes, I wanted to start this. See, I have told you average speed, but I have told you one more thing, that you have. Yes, yes, Zainab, you will be having classes. Yes, tomorrow. I hope you're available tomorrow.
Ma'am, tomorrow 6:30 I have bio tuition.
Okay, you're having bio classes.
Yeah, ma'am.
Uh, okay, then I'll just talk to the team once. I'll just see your schedule first. All right, I was not aware about your schedule. Okay, I'll just see it when your classes would be ending. At that time, I will arrange, or other time. If it is a little late, will it be fine for you?
Ma'am, like what would be the time?
When your bio classes are ending tomorrow?
8 o'clock. And in India time it must be 10:30.
Okay. So you are having your bio classes from 6:30 to 10:30.
Yeah, ma'am.
And what about after 10:30? Like if I give you half an hour break, 11 o'clock here, 8:30 there,
Yeah, ma'am. Fine.
it's fine.
It would
Yeah,
be one hour class, right?
yeah, yeah, it's 1 o'clock.
Yeah, ma'am. Fine.
Okay. I'll try to arrange your class at 11 p.m. tomorrow. I'll just talk once. If it's not possible tomorrow, because if it would be very late, so then I'll take your class some other day. I'll just take your schedule first. Okay.
Yes, ma'am.
Class, I wanted to start with this topic. So suppose you have a time like 2 p.m. So this is an instant of time. Instant of time means at a particular very fixed point of time you are calculating. Like this is the instant of time. T1 is equal to 2 p.m. Then you have the instant. Like if I tell you 6 p.m., this is an instant. Or one more example, if you take T3, if I'm telling you exactly at 2:10 a.m. So this is also an instant of time. Means this is exact point of time. So we call this as instant. Now, this is one case. Another case you have, this is the first case. Second case which you have is time interval. Instead of saying instead of saying at 2 p.m. or instead of saying at 6 p.m., if I give you an interval, if I tell you from 2 p.m. to 6 p.m. So see, can you see this is an interval, not an instant. Now this is an interval. Initially this was instant. If I give you an exact time and I ask you to calculate the speed at an exact time, that is instant. But if I give you an interval 2 p.m. to 6 p.m., 3 p.m. to 4 p.m., you'll be able to calculate a duration here. Like 6 minus 2 will be 4 hours. So 4 hours here would be what? 4 hours here. This would be the duration. So like this, if you are able to calculate the duration, that is time interval. So yesterday I had told you one thing also, that you have the classification of non-uniform speed further. You have uniform with you, uniform we have discussed. In non-uniform, you have two types of speeds. One is the average speed, which we have discussed. So we have discussed the uniform, which we have discussed the average. Instantaneous speed I wanted to discuss, and when to use instant and when to use average speed. So instantaneous speed is the speed at a particular instant when I am asking you. All right, if I ask you at a particular instant of time, so speed at a particular instant of time is called the instantaneous speed, not a duration. At a very, suppose at x1 point I have time t1, at x2 point I have time t2. So x1 is the position of the body at t1 this time, and x2 is the position of the body at t2. Now when you have the instantaneous speed and you have the average speed, question that arises, instantaneous speed is very easy to calculate. See, what will be the instantaneous speed? Instantaneous speed is the speed which is rate of change of distance. What is this? This is differentiation. So for instantaneous speed, you will differentiate distance. See, this will be the instantaneous speed. And what this will be? This will be the, see, this is instantaneous speed. And what is this? This is the distance. All right. So you have instantaneous speed and you have the distance here. All right. So this is how, and this is the time changing with respect to time. Now we have practiced differentiation so much that you should be aware of how you will be solving these questions. All right. You should be aware of how you will be differentiating it. Differentiation, integration, I have told you already, that will be used throughout the year. It won't be used just in the first chapter or second chapter. So this is what is speed. Now the question that arises is, when do you have to use the average speed? When do you have to use the average speed means the normal speed, distance divided by time. And when you have to differentiate it, differentiation of distance over time. So remember, whenever you have an instant is given. For example, exactly at t is equal to 2 seconds, or calculate the speed exactly at t is equal to 4 p.m. Like this, if you have something, exact instant of time is given, then you will be using instantaneous speed. If you are given a duration means you have two timings, one initial, one final. Like from t is equal to 3 seconds to t is equal to 6 seconds, calculate the velocity. If you have this duration with you, or for example, if I tell you from t is equal to 2 p.m. to t is equal to 3 p.m., like this, if you have this duration, in this case, you will be using the normal formula of average speed, that is distance divided by time. This you will be using. And here you will be differentiating it. So algebra will be used here for duration, and for instant, you will be differentiating it. I'll share questions also with you. First, note down these points. This note point is very important. Mark this also important when you are writing, because this will be only helping you further also to differentiate between average speed and velocities. Write it from here. Okay, class, I'll solve this question, but just answer in the chat column. Just read this and tell me, do you think instant velocity will be calculated or average velocity will be calculated? Both of you are right, Shaima and Zainab. Okay, Zainab, along with you, Shaima also must be having the exam on 15.
Yes, ma'am.
Shaima, do you also have your bio classes tomorrow?
No, ma'am.
All right, so you all have the exam on 15. Um,
Yes, ma'am.
so if I take your classes on Friday, Saturday, Sunday, the next Friday, Saturday, Sunday, will it be fine then? Because I think if you have the classes, if you have the exam on 15, then Saturday, Sunday, on Monday, all these four classes, even in the morning if you want. Because tomorrow I think it's becoming difficult to arrange the class. Yes, Zainab and Shan, I'm asking you. Is it fine?
Morning we have school.
No, no, not this week. Not this week. On Sunday, I'm saying the next Sunday. Okay, Sunday you people have your schools, no? Friday it must be off.
Yes, ma'am.
Friday it must be an off, no? So on Friday, Saturday, Sunday, I'll take your class. That's better, I think. Yes, both of you are available and fine with that. Friday, Saturday, and Sunday.
Yes, ma'am. But Sunday I could not be able to join.
Okay, Sunday let's leave. Friday and Saturday we'll cover them. Friday, I think major portion will be covered on Friday itself.
Yes, ma'am.
Okay, Friday. Okay. Fine class. Yes, so Zainab and Shaima correct. This is instantaneous. Why? Because it is saying at t is equal to 2 seconds. This is not giving you a duration from 2 seconds to something or somewhere. Exactly at 2 seconds. So see, you have the distance as x is equal to t square. Speed you have to calculate exactly at 2 seconds. So instantaneous is differentiation of distance with respect to time. Yes, class, we had discussed differentiation. Now you have to differentiate t square dt. You have to differentiate t square. Very easy. Jobita, can we start with you? Do you remember? T square, x to the power n, how we used to differentiate. T square is a very simple example we have. We have discussed such complex examples also. If you have t square, it's resembling to x to the power n. How we used to write? Yes, Jobita.
2 minus 1.
2 minus 1 would be the power. T to the power 2 minus 1. Something here would also be coming.
2.
2. Yes.
2 into
2. Yes, Shan. Answer is correct. I think you're mentioning the velocity, not the distance. Because we are calculating velocity. See, velocity is coming 2t, right? 2 into t to the power 2 minus 1. So we have 2t over here. So this is velocity. Now you know velocity's equation is 2t. We had the equation of distance. Now we have the equation of velocity. And at what time we have to calculate? 2 seconds. So 2 into 2, that is 4. So velocity will be 4 meter per second. Write it, class, quickly. Okay. Read this question, try this question, tell me the answer of first part at least. Second part I'll help, but first part all of you should try. At least I want the speed. Speed at t is equal to 1 second. The questions are very easy. We have done complex question of differentiation, integration, everything. Yes, only Shaima has answered. Zainab is also answered. Okay, good. Others, why only these two are answering? At least first part should have been solved by all of you. Sabiha, your answer. Hashid, Jobita, what is the velocity coming? Jobita, you had differentiated the previous part also. You would be able to differentiate this. See, it is saying speed at t is equal to 1 second. So this is very clear that it is asking us to differentiate it because it requires instantaneous speed. So we have the distance as x is equal to 3 t square minus 2t plus 1. Now, when we are asked to calculate the instantaneous velocity, 3t square, 3 here, This becomes 2t minus 2 kept here, and t to the power 0 will be 1 plus 0. So final equation of velocity is 6t minus 2. This is the equation of velocity that was required by you to calculate. What will be the value of this? You have to find out at t is equal to 1 second. So at t is equal to 1 second, this will be 6 into 1 minus 2. That is 4 meter per second. This is correctly calculated by Shaima and Zen. 2t for t, not 2t. We have just substituted t. See, only 2. This is 2 t to the power 1, right? So 2 is a constant. Leave the constant. You have t to the power 1. 1 will get multiplied here, and this minus 1. So what do we have? 2 t to the power 0. What is t to the power 0? It's 1. Any constant to the power 0 is equal to 1. This is 1. So 2 into 1 will be 2. In case of 3t square, why did we substitute 2t? We have not substituted. Okay, you are asking that. See, we have not substituted 2t. Look. 3t square you have. Now 3 is a constant. Keep it separate. What is now left? We are left with t square. How do you differentiate t square? 2 comes, power comes, n x to the power n minus 1. So n x to the power n minus 1. And then we had the 3 also. So what is this term? 2t. This is 3. Now tell me, is it clear? So we have the speed as 4 meter per second. Now the second part is saying, this was the first part. Second part is saying that time when body stops. See, if the body will stop, can anyone tell me what would be the velocity if the body stops? According to you, what would be the velocity if the body stops?
0.
0. Definitely 0. Very good. So what is the velocity's equation? You have the velocity's equation now as 60 minus 2. If the body stops, if this condition occurs, then velocity will be 0. So it means 0 would be equal to 60 minus 2. 2 will go here. So it will become 60 is equal to 2. T is equal to 2 by 6. So time will be equal to 1 by 2. Write it down. Any doubts if you have, let me know. Yes, Zainab, you can further divide it also. That will be 0.5. Others also answer. What's your answer coming? C. Again, this is exactly instantaneous. Now, how will you calculate here? You have the equation. Time is given as under root x plus 3. See, we always require x equal to something. You do not have to differentiate time. See, if you will differentiate dt over dt, that will be cancelled. You do not require to differentiate time. You have to differentiate velocity only. Okay, Shama has calculated both the parts. Very good. Others also, at least answer whatever answers you get. It's not necessary that your answer has to reach the final step. Okay, Zainab has also calculated. Whatever answers you are getting, you all should answer and at least try. I give you time so that you are at least aware of the question. And then when we discuss, you participate in this. Wherever step you leave the answer, you can answer till that only. That you have just calculated the equation. You're getting the differentiated equation like this. All right. Okay, Zainab. See, velocity is dx over dt. So firstly, one thing is clear, we require x. Let's square both the terms. This is t square equal to x plus 3. Fine, this is equal to t square is equal to x plus 3. And what is x equal to from here? T square minus 3. Can you see this is now again an equation which is familiar to us? All right, you know this equation already. Now you can differentiate this. So velocity here, this is equal to, when you differentiate t square, this will become 2t. See, we have differentiated this so many times. By now, these things should be on your tip. And minus 3. See, 3 is a constant term, that will be 0. So velocity is just 2t. See, this looked so complex. T is equal to under root x plus t. You're just getting 2t as your final answer. And you have to calculate the speed at t is equal to 2 seconds. So velocity is 2 into 2, which is equal to 4 meter per second. So Shaima's answer is again correct. Very good. You're good with the concepts. All the answers you're, this is because you have the habit of attempting. Zainab also has this habit of attempting. That's why I'm telling other students also, just participate. Whatever answers you're getting, no, just answer till that step. Even if you're not getting this answer, you would have got this equation, answer that only, so that I'll be able to help you, and that will give me an awareness about how much you have understood. All right, so just try to answer. If you are not able to solve anything while writing, while practicing, that time ask me. The next, at least I'll give you a hint so that you'll be able to calculate, because the questions which you are calculating yourself, you will be able to remember it. You don't have to even revise those questions. And the time when body stops, see, yes, velocity will be 0. So 0 is equal to 2t. 0 divided by 2, that will give you 0 itself. So 0 seconds. Yes, write it. The students also tell me this is clear. I hope it's not difficult. You're able to understand. Jobita, Sabiha, Hashid, understood?
Yes. Yes, ma'am.
All right, good. Hashid, you also, Sabiha?
Yes, ma'am.
All right, class, that completes with speed. Now, if you've understood speed properly, understanding velocity is not difficult. Understanding of velocity is very easy. Why? Because wherever you had distance, now we'll be using the term displacement. Reason is that rate of change of displacement is called as velocity. Rate of change of distance was speed. Because see, distance is a scalar quantity. So there is a difference between distance and displacement. Distance and displacement, they are not exact same things. You have one term as distance, other term is just a second, class. Just give me a second. Screen is sharing. So this is displacement. So distance, rate of change of distance would give you speed, and rate of change of displacement would give you velocity. This is the difference between distance and displacement, and speed and velocity. So further difference that arises is speed and distance. Both these terms, they are scalar. So you can directly add or subtract. These terms are vectors. So we have to keep the direction in mind. We'll be focusing on vectors once we reach the end of this chapter, because here in this chapter, vectors are not very important. We will not be using them. So after this chapter, I'll start with vectors. Now, what is velocity? Rate of change of displacement. Just put an arrow here that shows that these are vector quantities. Now, types of velocity again. If the displacement is changing in equal intervals of time, we say it's uniform. But see, this is a vector quantity. Magnitude and direction do not change with time. Magnitude means the number itself and the direction should not change with time. Magnitude means the value of velocity. Like it's 3 meter per second, 4 meter per second, 5 meter per second. That value should not change. And here direction also should not change. I'll just tell you in brief, you have vector quantities and scalar. In scalars, you just have the magnitude. What is meant by magnitude? Magnitude means just the number. We never talked about this direction when we were discussing this. So we will be just using the term magnitude. In vectors, you have the magnitude plus you have the directions also. That's why we have proper vector laws for the calculation of them, which we'll be studying later on. So that's why magnitude means the number itself. If I say velocity is minus 3 meter per second, magnitude means just this 3. If I say velocity is plus 3 meter per second, magnitude means this 3. Means just the number without the sign is called magnitude. That tells you the value, numerical value. So in case of uniform displacement, they shouldn't change. In case of non-uniform displacement, unequal intervals of time or unequal displacements could be covered. That will give you non-uniform. Or it can happen magnitude is changing, direction both are changing. How can the directions and magnitude change? See, this is the further classification of non-uniform. Magnitude can also change direction. You will see circular motion. In circular motion, what will happen? See, if the direction of velocity is always tangential. I'll tell you this when we will be discussing circular motion. If direction of velocity is tangential, look at every point, the tangent to the circle is different. Look. So it means you will have different directions of velocity in every second. So it means this is non-uniform. Like this, you have the directions of uniform and non-uniform. And again, non-uniform is also average and instantaneous. For average, again, the same formula. Instead of distance, you have the displacement. So total displacement divided by total time would give you the average velocity. Like here, if you have to calculate the average velocity, this is an example. Total displacement. See, earlier we used to add a body has started moving from A, goes to point C. and then comes back to this point B. Fine, here this is what it is saying. Had it been the question of average speed, we would have taken this distance plus this distance, right? The entire distance, this plus this we would have taken, right? From here to here. The person is going from A to C, then C to B, this we would have taken. But in displacement, I have told you displacement is the shortest path. So you do not take the entire separation. You just place your initial point. Initial point is this. Where is the final point? It is going to point C, but it is coming back to point D. This is the final point. What is this separation? See, this, okay, it is coming back to point D, not B. It is going from A to C, then coming back to B. All right, forget this D point. Just let's make this, just forget this. D is just a marking for the direction. Body is going from A to C, coming to B. Initial is this, final is this. So when calculating the average speed, average velocity, just put an arrow to differentiate it. Yes, I'll explain again. So what is the displacement? This is the displacement. Only this example, Zainab, or just the or the above part?
No, ma'am, example.
Example, I'll give you. Look. This question says a body started moving at this point from this point A. Goes to this point D. How much distance is covered? 10 meters. Then goes to point C. How much is the distance given? 5 meters. And then comes back at a point here, which is marked as B. And this distance that is covered is 3 meters. We have to find out average velocity. If this was a question of average speed, we would have calculated total distance by total time, right? This is how we calculate total distance we take divided by total time. So for total distance, see, what would have been the total distance? 10 plus 5 plus this 3, right? 10 plus 5 plus this 3 meter. So all these 10 plus 5 plus 3 meters, all these would have given us the total distance because that is the total path covered, right? Now we are going to ask to calculate the total velocity, total speed, right? Because we have to, we don't have to find out total distance, so we won't be calculating the average velocity. We have average velocity right now. For average velocity, we require total displacement. We do not have to use total distance because this is a case of average velocity, not speed. So we have total displacement by total time. So what is the initial point? The person has started moving from A point, goes to D, goes to C, but comes back to this final point B. So B is your final point. And what is displacement? Displacement is the shortest path that is traveled. Means just separation between the initial and final point. This separation. That's it. So if this is 10, right? This entire is 5. This is 10. So we have to find what is this point from B to D. See, if this is 5, 3 meters is this. So this will be 2 meters. Yes or no, class? Tell me. 2 meters, this is clear? Look here.
Yes, ma'am.
This is 5 meters. This is 3 meters. So what is the leftover part? This will be 2 meter here. And now see the separation between the initial and final point. This is 10 plus 2. So total displacement would be 12. 10 plus 2. And what is the total time? It is saying 3 seconds plus 5 seconds plus 2 seconds. So that is again 10. So 1.2 meter per second is the velocity. Average velocity. First tell me, is this question clear to all of you? Is this example?
Yes, ma'am.
Fine. Write it till here, then write down this question. Just add this also, make it as a note point. See, in this question, without the conversion, it would be done. You can leave the answer in kilometers because this is, but see, this is given in minutes. You have to convert one in the same unit. See, this says that, let me discuss it now. I hope you all have at least tried it. See, this says a man walks on a straight road from his home. He has started moving from his home to market. And this market, this is situated, this is the market, let's say, and this is situated 2.5 kilometers away. It's, see, this question is a very famous question. This repeats itself in the final exams also, in the half yearlies also, in the tests, unit tests also. So just to mark this important somewhere in the question, wherever you have written it. Okay, so he is moving with a speed of, initially he is moving with a speed of 5 km per hour. He is moving here 5 km per hour. Now he sees that the market is closed. He instantly turns and walks back home with a speed of, now he increases the speed and moves with the speed of, initially he was moving with a speed of 5 km per hour. Now he is moving when he is returning back. See, when he is returning back, he is moving with a speed of 7.5 kilometers per hour. Fine. You have to find out what is the magnitude of average speed and average velocity for 0 to 30 minutes. See, what is the time that is taken from home to market? You know, what is the distance when the person was moving? Distance was 2.5 kilometers. This was the distance, right? And what was the speed? Speed was 5 kilometers per hour. How do we calculate time from here? What is the time? Tell me. You have the distance, you have the speed. What would be the time? All of you answer in the chat.
Distance by speed.
Distance by speed. Very good, Shan. It would be distance by speed. So see, time taken from home to market. It would be distance divided by speed. See, they are in the same unit, so we'll get this as half an hour. That will be 30 minutes. Now see, one thing we know, from here to here, when he went, this took him 30 minutes. Firstly, we have to calculate the speed and distance from 0 to 30 minutes. It means when he was going from home to market, this distance and this speed you have to calculate. Class, tell me, do you think the average velocity and average speed in the first part, it would be different or it would be the same?
It would be same.
It would be same. Very good. Reason is that it is on a straight line. This is the initial point. This is the final point. So distance is also 2.5 kilometers. Displacement is also 2.5 kilometers. We are just talking about 0 to 30 minutes class. Why 30 minutes? I am marking it here because see, time taken from home to market came out to be 30 minutes. So it means this we are calculating. So here the distance and displacement both are same. Distance would be equal to the displacement. Now see, this distance is same for average velocity, for average speed, anything when you are calculating. It would be 2.5 kilometers. See, this is in kilometers. So I will, now look here, Zainab, you were asking about the unit. If I'm writing this as kilometer, so I'll not divide it by minutes. I'll get the unit as kilometer per minutes then. Kilometer per hour you can use because that is the unit which is mentioned here in the question. Right, that's why you can use in this question as kilometer per hour. Otherwise, you have to convert if two things were given. Suppose one was in minutes, other was in meters, then you had to convert. So you will not put this as 30 minutes. You will put it as 0.5 hour. Why? Because we'll convert, this is half an hour. Half an hour is 0.5 hour. So this becomes 5 kilometer per hour. What is this? This is the average speed. This is the average velocity. This is the answer to the first part. A part. Tell me class, is the A part clear?
Yes,
Yes,
ma'am.
ma'am.
Oh, now you have the second part. A part is simple because we know from H to M, that is home to market, this was all what we had to calculate. Now this is saying 0 to 40 minutes. Where would 40 minutes lie? We have no idea about 40 minutes. We just have 0 to 30 minutes, right? 0 to 40 minutes, we do not have any idea. Now what we'll do? We just have the information about 0 to from home to M. That too we have calculated. So let us do one thing. The way we have calculated it from home to market with this speed, let us calculate it. Let us also calculate from market to home. So we have this velocity, we have the distance, we will get an approximation time. Let's see how much he is taking the time when he is going home. So when in the second part, he is going from market to home, distance is still 2.5 kilometers. Speed is 7.5 kilometer per hour. So again, the time that would be taken. Look, T is equal to 2.5 divided by 7.5. That gives 1 by 3 of an hour. So 1 by 3 of an hour means into 60, 20 minutes. It means when he went, it took him 30 minutes. When he is coming back, it took him here 20 minutes. It means if I divide this time into two equal halves, here in the first half, he would have covered 10 minutes. Here in this half, he would have covered 10 minutes. Sorry, this is the first half. From market, he is coming back. No. So 10 minutes here, then 10 minutes here. Right? Because this total is 20 minutes. So first half, he is covering 10 minutes. Then the later half, he is covering 10 minutes. Tell me, class, till here, this is clear? Division of time?
Yes, ma'am.
Okay. Now we have to calculate 0 to 40 minutes. 0 to 30 minutes is this plus this 10 means somewhere in the middle point. This midpoint he has reached, that you have to calculate. Because see 30 plus 10, that would give you the 40 minutes. So since it is given from 0 to 40, this. Now we have to calculate average speed and average velocity. Now tell me, in this question, will it be same or different?
Different.
Different. Reason? Reason? Reason is that distance and displacement both are not same here. See, distance is 2.5 plus this half of 2.5 that is covered. Right? What would be this separation? This would be 1.25 where he is covering 10 minutes. This separation would be 1.25 where he is covering 10 minutes. See, person is going from market to home. This entire was 2.5. Here this would be 1.25. Here it would be 1.25. Time taken here is 10 minutes. Time taken here is 10 minutes. So total separation, total time that is calculated, that we have to find out. Second part, see, in the second part, have you understood this part? How have we got 20 minutes? From market to home, we have calculated 20 minutes. This is clear?
Yes, ma'am.
Okay. See, if you divide 20 minutes by 2, that will give you 10 minutes each, right? That will give you 10 minutes each for these. So see, okay, do one thing. Just write down the first part at least. Second part, I'll explain later. At least first part you all write. Some things would be clear from the first part, then I'll explain it again. Write the first part at least, this part. Do not write down these things, just I'll explain later. And one more thing, class, from the next weekend, Saturday, Sunday, we'll be having 2-hour classes. I have told you earlier already that your syllabus is very vast, and if you go with this duration only, your syllabus will not be able to complete. So from the next week, we'll be having 2-hour classes, 6:30 to 8:30 here. And extra classes, I'll inform the other students. Write it till here. In the next class, I'll explain you the second part. Write it till here, this part, just write it. Text me done. And if completed, start leaving the meeting, because your portion is always, it won't be completed in this few time, and you have your time up. You can leave also if you have completed till here. In the next class, I'll explain you the second part, because that will require a little time. Okay, class, thank you so much then. 2 hours class from the next week.
Thank you.